The problem that we are going to discuss today is from the recent May Cook-Off, and the problem name is the last problem. Difficulty level of this problem is easy and its prerequisites are prefix sums. So let's have a look at the problem statement. So in this problem, you are given a matrix that extends infinitely to the right and down, filled with values as shown below. So this is the matrix. So we have 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10. So you do see a pattern over here, right? That it is a stair-like matrix. So not exactly a stair, this kind of matrix. So the next numbers over here will be 7, 8, 9, 10, and here it will be 11, 12, 13, 14 and 15, right? So this is the idea of the matrix. Now let us see what we have been given. So let x comma y denote the cell in the xth row and the yth column. So for simplicity, I'm going to say it's not x comma y. I'm going to use it as r comma c, so that it's not confusing with coordinates. So I'm going to use r comma c in the explanation. So the upper cell 1 comma 1 contains an integer 1, yes, and you begin at cell x1 y1 and must walk into the cell x2 y2 by only moving right and down. So formally, from the cell x comma y, in one step you can move to the cell x plus 1 comma y and x comma y plus 1. So basically what they are trying to say is, so we take some arbitrary cells, say 4. So from this cell we can only go to the right cell or the down cell. We cannot go left or above. Okay, so this is what they are trying to tell us by this statement. Now the value of a path is the sum of the values in all visited cells including x1 y1 and x2 y2. Okay, so let us say a path is from 1 to 8. So here this is one path, right? So the value of a path is 1 plus 3 plus 5 plus 8. So the value of this path is say 4, 9 and 17. Now we need to calculate the maximum possible value on the path from x1 y1 to x2 y2. So easy. So let's say we have a path from 1 to 8. So this is one possible path. This is again another possible path, and there are many such possible paths. Now we need to take the maximum of these values as our answer. So let us understand this better with the help of a sample case. Let us consider this sample case. So here we have r1 comma c1 as 3 comma 1. So let us see which is 3 comma 1. This is 3 comma 1, this index. And let us see what is r2 comma c2. It is 5 comma 2. So this index, right? Now let us see all the paths that lie from this to this index. So the first path is just a minute. So the first path is 6, 9, 14, 20. So let us calculate the sum of values on this path. So path 1, it is 6 plus 9 plus 14 plus 20. So if you see, the sum is 34 plus 9, which is 43, plus 6, which is 49. The next path, it is 6, 10, 14, 20. So second path, it will be 6 plus 10 plus 14 plus 20. So the value of this path is 16 plus 14, 30 plus 20, which is 50. Now the third path, it is 6, 10, 15, 20. So 6 plus 10 plus 15 plus 20. So if you check out, this path has sum is equal to 51. So the third path has maximum sum. Therefore, our answer for this test case, it is 51. Right. Now, did you observe something from this? We get the maximum answer when we go down first and then go right. So hold on to this observation. We will strengthen this observation with another case. Now let us take a case where we have our r1 comma c1 is equal to 1 comma 1. That is the first index, and let our r2 comma c2 be equal to 2 comma 5. So 2 comma 5 is the second row and fifth column. So 17. Now let us calculate all the paths from 1 to 17. So path 1, it will be 1, 2, 4, 11, 7, 11, 17. So it is 1 plus 2 plus 4 plus 7 plus 11 plus 17. So the sum of this, it will be 3, 7, 14, 25 and 42. The next path, it will be 1, 2, 4, 7, 12, 17. So basically instead of 11 we have 12 over here. So if you see, when we convert one right to a down, there is a addition of plus 1. So the value will be 43 over here. Now we convert another right to down, so it will be basically, this will be the path 1, 2, 4, 8, 12, 17. So here 7 will become 8 and the value will become 44. In the same way, this, if we convert, then the value will become 45. And finally, if we convert the path to this, so 1, so the final path will be 1 plus 3 plus 5 plus 8 plus 12 plus 17. So here, if you check out, the value will be 9, 17, 29 plus is equal to 46. So 46 will be our answer. So answer for this test case, it will be equal to 46. So what we have seen, that the best possible strategy to use over here is first go down and then go right. Cool. So what do we have to go down from? So we have R1 comma C1. So R1 to R2 comma C1, and then we go from R2 comma C1 to R2 comma C2. So this is a fairly clear strategy and we have gained it through observation, right? Now let us see how we can implement this strategy. For the implementation part, the first thing to do is that we have to pre-compute the infinite matrix. Now pre-computation is necessary due to the constraints that we have been given, that R comma C are both between 1 and 1000. So basically we cannot create this matrix over and over again, right? So pre-computation is necessary. Now the second thing what we discussed is obviously, so through the example we discussed that if we want to go from 1 to 9, so the best path is to go down first and then go right. Right. Now what do we do? So this is R1 comma C1. So we discussed that first we will go from R1 comma C1 to R2 comma C1, that is exactly down, and then we will go to R2 comma C2. So first we will sum values from R1 comma C1 to R2 comma C1, and then we will sum values from R2 comma C1 to R2 comma C2. So this was the implementation part. Now the question is, how do we compute the infinite matrix? So here's what we do. So first I will just calculate the first column. So this is the first column, right? So I will just calculate this column. What do you think this column is? This column is the sum of first I natural numbers, right? So 1 is 1, 3 is 1 plus 2, 6 is 1 plus 2 plus 3, and so on, right? So for the first column, I will just write I into I plus 1 by 2. So what is this? This is inf of I comma 1. This is I into I plus 1 by 2, right? Now I will, once I have got the first number, then I will calculate the corresponding row to this. So let us consider the first row. How will we calculate this? So 2, how will we calculate the second number in this row? So the second number in this row, it will be calculated by the recurrence relation inf of I comma j, that is this number, will be equal to the previous number, which is 1, I comma j minus 1. Now what do we add over here? So this is the second number in the row. So j will be equal to 2 and I will be equal to 1. Now if you see, as we go to the right, j gets incremented, right? So 1, 1 will be added to the previous. So it will be equal to plus j minus 1 and also I minus 1, because as we go lower this is 3, so 1 should again get added, so it is plus I minus 1. So this recurrence relation will hold. Now let us check it out. So 2, is it equal to 1 plus 2 minus 1 plus 1 minus 1? Yes, the answer to this is 2. Let us check out 4. So 4, is it equal to what? J is equal to 3 now. So 2 plus 3 minus 1 plus 1 minus 1. So yes, the answer will be 4. So we have our final recurrence relation, that inf of I comma j, it is equal to inf of I comma j minus 1 plus I minus 1 plus j minus 1. This is our recurrence relation for calculation of each row of this matrix, and we can calculate this for each row. So like this we have pre-computed the whole matrix. Now as we are done with the pre-computation part, let's directly proceed to the C++ implementation. So starting off with the C++ implementation, let us first see the code for pre-computing the matrix. So it is exactly as I showed. First we will compute the first column, which will be given by I into I plus 1 by 2. That is the sum of the first I natural numbers. Now we will calculate the corresponding numbers in its rows. So we have the recurrence relation inf of I comma j, it is equal to inf of I comma j minus 1 plus j minus 1 plus I minus 1. So using this we can calculate the pre-compute the infinite matrix. Now here I have just written a print matrix statement. Now let us come to the main part. So in the main part, as I told, first we will go from R1 to R1C1 to R2C1 and then to the right. So here this is the first part, that we go from R1 to R2, where sum plus is equal to inf of I comma C1. So here we are in the C1th column, and next we go from R2C1 to R2C2, that is we are in the R2th row. So here it is basically sum plus is equal to inf of R2 comma I. Here just remember, you have to calculate from C1 plus 1, otherwise you will be double counting, right? So this should be kept in mind. And finally we get our sum, which you should output on a separate line. So this was the explanation, and thank you.